AI's role in colonizing Mars, the future of space exploration. The first inhabitants of Mars won't be human. Long before anyone takes a first step on the red planet, a new kind of pioneer will have already built our first home, secured our survival, and laid the foundation for a new branch of civilization. And these pioneers, they're intelligent machines. For decades, we've dreamed of planting a flag on Mars. But the dream isn't just about visiting anymore. It's about staying. It's about building a second home for humanity. Before we can get there, though, we have to solve a set of challenges so huge they make the Apollo missions look like a weekend road trip. And the key to cracking nearly all of them is artificial intelligence. This isn't some far-off sci-fi dream. This is the blueprint for the future of space exploration, a future where AI leads the way, turning the desolate Martian landscape into a place we can call home. Section 1. The Monumental Challenge of Mars. Let's be real. Colonizing Mars is probably the single greatest project humanity has ever dared to consider. The sheer scale of the problem is just staggering. Mars is a world that is actively hostile to life as we know it. First, you have the environment itself. The atmosphere is so thin, less than 1% of Earth's, that it offers almost zero protection from the constant blast of solar and cosmic radiation. Temperatures can swing from a balmy 20 degrees Celsius near the equator in summer down to a crushing minus 153 degrees Celsius at the poles. And then there are the planet-wide dust storms that can blot out the sun for weeks, crippling solar-powered systems. Then there's what you might call the tyranny of distance. On average, Mars is 225 million kilometers away. That's not just a long flight. It creates a crippling communication lag. A signal can take anywhere from 4 to 24 minutes to travel one way. A real-time conversation is impossible. You can't remotely pilot a rover with a joystick when it takes almost an hour just to see if your last command worked. Every problem, every malfunction, every unexpected discovery has to be handled on-site, right then and there. And finally, there's the cost. Every single kilogram we launch from Earth costs thousands of dollars. We can't just ship a pre-built city to Mars, it's not happening. We have to build it there. Section 2. The solution arrives. AI as the vanguard. This is where AI comes in. When you're faced with a lethal environment, a crippling communication delay, and an impossible logistics problem, artificial intelligence isn't just helpful, it's absolutely essential. AI gives us the one thing we absolutely must have for a Mars mission: autonomy. Because of that communication lag, we can't micromanage an outpost from Houston. We need systems that can think for themselves, machines that can analyze a situation, make a call, and act in it without waiting for an okay from a human 225 million kilometers away. We need artificial super astronauts, robots guided by advanced AI that can work on their own for weeks, months, or even years. These AI-driven explorers don't need to eat, drink, or breathe. They're unfazed by radiation and wild temperature swings. They can work 24/7, tirelessly getting Mars ready for us. This slashes the mission's cost and, more importantly, the risk to human life. The only practical way forward is to send these silicon-based pioneers first, to prepare the ground for the fragile species that created them. Section 3. The first pioneers, robotic builders and miners. So what's the first job on the list for these AI pioneers? Construction. Long before the first crewed starship even thinks about landing, a fleet of autonomous robots will be hard at work building our first home. The key to this whole strategy is something called in situ resource utilization, or ESRU, which is a fancy way of saying live off the land. Instead of shipping everything from Earth, we use the resources already on Mars. And AI will be the master foreman of this interplanetary construction site. Companies like AI Space Factory have already developed incredible concepts for this. They won a NASA challenge by 3D printing a habitat prototype from a basalt composite, a lot like what you could make from crushed Martian rock. Imagine robotic printers guided by AI roaming the Martian surface. They'd scoop up the red soil, or regolith, melt it down, and print structures layer by layer. These AI machines could build everything from landing pads to entire habitats, all without a single human astronaut in sight. But shelter is only half the battle. To survive, you need water. And Mars has it, locked away in huge deposits of ice under the surface. AI-controlled mining bots will be sent to find and extract this precious resource. Guided by ground-penetrating radar and AI-powered analysis, these machines will pinpoint the best ice deposits, drill down, and start harvesting. That water can then be purified for drinking, split into hydrogen and oxygen for breathable air, and even combined with carbon from Mars's atmosphere to create methane, the rocket fuel we need for the journey home. The ability to refuel on Mars is the real game-changer for making interplanetary travel sustainable. Section 4. Engineering a habitable world, AI as the life support system. Once the buildings are up and the resources are flowing, AI's job shifts from construction worker to colony manager. It becomes the silent, always-on brain of the life support system, the one thing that absolutely cannot fail. Inside the habitats, AI will meticulously manage a closed-loop ecosystem. It'll control the air pressure, regulate oxygen and CO2 levels, and recycle every last drop of water. It will oversee food production in high-tech hydroponic farms, where AI algorithms monitor the health of every single plant. The AI can tweak nutrient levels, light, and humidity to squeeze out the maximum possible yield, ensuring the colonists have a stable food supply. Outside, the AI will be our ever-watchful sentry. It will act as a planetary weather forecaster, analyzing data from orbiters and ground sensors to predict those colossal dust storms Mars is famous for. This gives the colony time to conserve power, protect equipment, and keep everyone safe. AI can spot patterns in these massive data sets way faster and more accurately than any human team back on Earth ever could. Section 5. The autonomous brain of the colony. This level of autonomy isn't just theory, it's already happening. NASA's Perseverance rover on Mars right now uses an AI called AutoNav to navigate the tricky terrain of Jezero Crater all by itself. It analyzes images of the path ahead, spots hazards like big rocks or steep slopes, and plots a safe course without waiting for commands from Earth. This has massively sped up its exploration. Now imagine scaling that up. Instead of one rover, picture a whole swarm of interconnected robots, all coordinated by a central AI. They could work together to build infrastructure, set up science experiments, and respond to emergencies. If one robot breaks down, the AI simply reassigns its tasks to others in the network, making sure the mission doesn't miss a beat. If an amazing scientific discovery is made, like a new mineral, the AI can redirect its robots to investigate, just as Perseverance can already autonomously identify interesting rocks to sample. This isn't about replacing human decisions, it's about upgrading them. The AI will handle the millions of tiny, moment-to-moment operational choices, freeing up the human crew to focus on the big picture: science, exploration, and expansion. Section 6. The human element. AI as a partner. So what happens when people finally show up? They'll step onto a planet that's already been prepped for them, with shelters built, water flowing, and breathable air ready to go. But AI's job won't be done. It will transition to its most important role yet, a partner to the human crew. The communication delay means astronauts won't have an instant lifeline to mission control or medical experts. In that situation, AI becomes a critical crewmate. It can act as a medical diagnostic tool, helping astronauts manage their health. It could even be a psychological support system, providing companionship and monitoring for signs of stress and depression, a vital task for a small group of people isolated millions of miles from home. The AI will manage schedules, monitor the health of every system, and offer data-driven advice, taking a huge mental load off the astronauts. In an emergency, the AI could be the first responder, guiding the crew through a complex repair or medical procedure way faster than they could by flipping through a manual. This human-machine partnership will be the foundation of a successful Martian colony. Section 7. The Grand Timeline and a New Spatial Age. Colonizing Mars won't happen overnight. It's a multi-decade effort that will unfold in phases. The first uncrewed robotic missions dedicated to construction and resource mining are a major goal for the space industry. Some optimistic timelines suggest these robotic pioneers could head to Mars in the late 2020s or early 2030s to lay the groundwork. As for the first human landings, timelines are still very much in flux. While ambitious goals from private companies target the early 2030s, NASA is looking toward a 2040 timeframe, and many experts agree that feels more realistic given the immense technological hurdles. From there, the colony will grow, with AI assisting every step of the way, from building bigger habitats to maybe even beginning the centuries-long dream of terraforming. We're at the dawn of a new spatial age, driven by the incredible combination of space exploration and artificial intelligence. And the technologies we pioneer for Mars will have huge impacts back on Earth. Think autonomous construction, closed-loop life support, and sustainable resource use. These could revolutionize how we live right here. Of course, this future brings up some fascinating questions. What does it mean for humanity if the first inhabitants of another world are machines? This isn't about replacing people, but recognizing that our greatest triumphs will come when we work together with the intelligent systems we create. CTA. This journey to Mars will redefine not just our place in the cosmos, but our relationship with technology. What are your thoughts on this new spatial age? What part of this journey would you be most excited to see in your lifetime? Let us know in the comments below. And if you want more deep dives into the future of tech and space, make sure to subscribe and hit that notification bell so you don't miss what's next. Conclusion: the dream of colonizing Mars is shifting from a distant fantasy into a tangible technological plan. And AI is the engine making it happen. It will be the scout, the builder, the life support system, and the tireless partner that makes a human future on Mars possible. It will brave the harsh frontier first, autonomously building our shelters, mining our water, and making sure our survival systems are a go. When humans finally set foot on the red planet, we won't be arriving as conquerors of a new world, but as inheritors of a home that was patiently and intelligently built for us. The first footprints on Mars may be human, but they will be following a path laid by the silent thinking machines that got there first.